Welcome to this quick tip presentation about stress linearization using Autodesk Nastran In-CAD. Stress linearization is typically leveraged when you perform finite element analysis of pressure vessels in accordance with ASME Boiler and Pressure Vessel Code Section 8 Division 2. You can use the stress linearization utility to graph specified stress tensors along a stress classification line. Stress linearization will extract the membrane and bending results that comprise the total stress PM plus PB. This is an image of the stress linearization window in Nastran In-CAD. In Area 1, the local stress tensor selection at the top left-hand side of this dialog allows you to choose which result to plot in the graph. The green button is utilized to save the numeric result in a CSV file. The stress linearization graph displays the local stress tensor results along the currently defined stress classification line. The linearization controls allow you to specify the first and last points to define the SCL. The positive T direction is defined from the first point to the second point. The stress linearization results are displayed for both the max shear stress and the von Mises stress. Let's go ahead now and enter into the software and take a look at how we utilize the utility. So once you are inside In-CAD and you have performed your analysis, here you can see that I have a pressure vessel, head, and nozzle, and I want to perform some stress linearization. In the ribbon bar you can access the stress linearization tool, which will bring up this dialog window. So maybe the first thing that I want to do after that is zoom in on the model where I want to define my stress classification line. You can see that I have a first and last point. These will be utilized to define the t-axis. Keep in mind that it's not completely arbitrary, first of all, where on the model you do this, and second of all, the positive t direction is defined from the first point to the last point. So I can do this in a couple different ways. I can define the node number, I can type in x, y, z points, or I can come down to the geometry itself and select a point on my geometry. Now keep in mind I just selected a point on the inside of the vessel, so if I go to the last point and I define my next point on the exterior of the vessel, this defines the positive t direction for my geometry. The next thing down on this dialog window is the number of divisions. So it's creating for me 10 data points along the stress classification line, and you can increase or decrease that. Now that we have the t-axis defined, the next thing that you can do is define either the n-axis or the h-axis. So this has a very similar dialog where you can either define the node number or input x, y, z coordinates, or again, you can select something on your geometry. I'm going to go ahead and leave it at 0, 0, 0. So now that you have that defined, you can begin to interrogate your various results. We can look at the n tensor, the t or the h direction, or maybe what you want to do is export all this data to an Excel document. So I can press this button right here to do that. Once I do that, change to an appropriate directory structure. I'm going to go inside my Autodesk folder, and I'll just save it as a particular name. And now that should export the data. If I browse into the folder and open up that Excel document, now I can see all the information in an Excel spreadsheet. I hope you enjoyed this quick tip. Have a good day.